Hey guys, how you doing? This is Coach Scott with Purple Wave Chemistry. Let's dig into this and let's have a little bit of fun and let's understand about an exothermic reaction. So I've got something on the screen here. I've got a solid barium hydroxide is added to a solution of hydrochloric acid to produce aqueous barium chloride and water. So the test tube feels warm. Let's see what we've got here. Let's write down our facts, right? So it says I have solid barium. Look at my trusty periodic table, and barium. Write it down. Ba hydroxide. So hydroxide, I remember, is on my trusty sheet of polyatomic ions. OH, and I've noticed that barium is in group 2, so that's a +2, and hydroxide, when I look on my sheet, that's a -1, so that means I need 2 hydroxides to balance out charges. So that's that typical, erase those. So again, I would write those down until you really get the hang of what's going on. Of course, I need parentheses there. And it said that was a solid, so we'll put an S there. Is added to a solution of hydrochloric acid. So it's a solution, so that means the HCl is dissolved in water. So we're going to put aqueous. To produce, there's the arrow, barium chloride, so barium Ba, Cl, barium is +2, chlorine is -1. Again, because barium is in group 2, chlorine is in group 17, which means it's -1. That means I need 2 chlorines. Let's take my eraser, get rid of that +2. Alright, let's see what else. And water, BaCl2 and H2O. Now, before we go anywhere, let's go ahead and balance it. I've got 1 barium on that side. I've got 1 barium on this side. I've got 2 hydrogens. I've got 1 hydrogen. So let's put 2 right. Oh, no, I've got 3 hydrogens. Yeah, we're going to need a 2 there to at least balance it out. Oh. So I got 2. So I got 2 HCl's. So I got 2 hydrogens. I got 2 hydrogens. That's 4. Got 2 chlorines now. Yep, that's good. And I got 2 oxygens. I think if I put a 2 there, that gives me 4 hydrogens. That's what I got. 2 oxygens. I'm good. Okay. So let's see what's going on here. So I've got my reactants. It's my fault. Let's go ahead and do this right. And that's just water, liquid, L. I got my reactants there. And let's see. It's not very hot. It doesn't say anything. We'll put like 2 bars there. So I've got a lot of potential energy there because, well, I know it. The test tube felt warm later, so that has to come from somewhere. So let's add 4 bars there for potential chemical energy. So I mix those 2 together. I don't add anything into the system, so just the system things are going on. So those are my products. All right. So my products, after I mix them together, it's trying to take this energy and move it over there to the thermal energy because it starts to get hot. So it does. So now I've got a lot of thermal energy here. Again, I'm conserving my energy. Okay? And of course my chemical energy goes down a little bit. Okay. So now, if I set this test tube in my little rack, it feels warm. right? Because this potential chemical energy was transferred to the thermal side, right? Whenever I combined the barium hydroxide and the hydrochloric acid together, it got really hot actually. So, as it sets for a bit, that energy, or that Q, is doing what? It's going out of the system into the surroundings. It's leaving the system, it's going into the surroundings because energy has to be conserved, right? Now, as it leaves, it's going to leave what? Well, the heat, if you would, is going to go down, and of course, our potential stays about the same. So we're going to call these products later, over time, when they lose that heat. Okay, now let's see what our curve looks like. At the beginning, my chemical energy is pretty high. Oh, not that. Let's go over there. So my chemical energy, this is the E, I'm going to just put energy right there. My chemical energy is high, and then it starts and it drops down lower. So this might be my reactants. These are my products. Okay. So where did this energy go? Okay, so the energy here was given off right there. Right there. So this reaction produced energy, and it was given off from the system into the surroundings. So we would say that energy was given off, or it was exothermic. So this reaction would be exothermic. Okay, my reasoning, back too quick. Oh, way too quick. Calm down, there you go. So my reasoning behind that is exothermic because the solution became warm, because energy is flowing from the warmer reaction system, all right, to the cooler surroundings. Okay? So Q flew. Energy that's being released can be seen as one of the products, all right? Because this thermal energy left the system, the ECH of the reactants must be higher than the ECH of the products, okay? And then I drew the 4 bars on the ECH of the reactants and 2 bars for the ECH of the products in the bar graph, okay? Because when I increased the ECH, or the thermal energy, rather, ETH, the system became warmer than the surroundings. And so there's an energy flow out of the system, okay, to the surroundings, and then ETH will return to its original level. And that way we're conserving energy, which we have to do in everything. So that's what an exothermic is. Hopefully that helps you understand that a little bit. And anyway, any questions, I'll answer them before we have a test. Anyway, this is Coach Scott saying, have a great evening. And hullabaloo, connect.